Hello everyone. Today we are discussing about computer architecture. So if you are interested with these topics, keep watching us. Stay with us. Like, comment, and share. Subscribe us. Okay, let's go to the video. So this is our topic, computer architecture. So I am doing this like article. So discuss about computer architecture. So here first we have introduction part. So in here computer architecture is a foundation of modern computer systems. So it focuses on the structure and behavior of a computer's component and how they work together to execute instruction, process data, and perform tasks efficiently. And this article explains the fundamental concept required for computer architecture, the structure of a computer system, basic performance concept, CPU functions, advanced processor techniques like pipelining and superscalar execution, and Flynn's classification of parallel architectures. So in here main topic is basic structure of a computer system. So first thing is main functional unit of a computer system. Main functional is input unit, output unit, memory unit. It means primary and secondary, and central processing unit, CPU. It means CU, ALU. You know ALU means arithmetic logic. It doing arithmetic operations. Next we have system interconnection. It means buses. And next topic is role of each unit in the data processing cycle. So we discuss about one by one. So this is our first unit, input unit. So in the input unit, capture raw data and instruction from external devices like keyboard, mouse, scanners, those things, and convert them into machine level form. In the memory unit, I discuss about primary memory. It means RAM, and secondary memory. In the primary memory, temporarily stored data and instruction currently being processed. In the secondary memory, provides long-term storage for files and programs. And next, CU means control unit. It manages all coordinates, all operation of the computer. It controls instruction fetching, decoding, and the movement of data. Next, ALU. I discuss about ALU means arithmetic logic unit. So in here perform all arithmetic operation like addition, subtraction, and logical operation like AND, OR, those things. In the output unit, it converts process data into human understand output from the monitor, printer, scanner, like last one is buses. Buses means acts as communication channel carrying data, control, signal, and addresses. Next topic is basic operational concept. In here we have four basic concepts: fetch, decode, execute, and write back. Next we discuss about how this each works. So first one is fetch. Fetch means the CPU fetch the next instruction from memory using the PC. PC means program counter. And decode. In the decode, the control unit interrupts what operation the instruction require and identify the need operations. Next one is execute. Execute means the ALU or other processor component carry out the operations like arithmetic, data movement, branching, those things. And in the write back, it means result are stored in register or memory. So that one is the last operation. So next we discuss about data transfer between memory and the processor. So we have mainly three buses. First one is address bus, data bus and control bus. In the address bus, CPU specify the location in the memory access, and data bus transfer the actual data between CPU and memory, and control bus sends signal such as memory read or memory write. The CPU issues a read-write signal, specify the memory address, the transfer data over the data bus. Our next main topic is basic performance in a computer system. So in here mainly von Neumann architecture and Harvard architecture. First we discuss about von Neumann architecture. In here von Neumann architecture is a computer design where program instruction and data are stored in the same memory and travel through the same bus. So next we discuss about some differences between von Neumann and Harvard architecture. So mainly have memory in von Neumann architecture shared for instruction and data. In Harvard architecture separate instruction and data memory. Buses von Neumann architecture has have single bus, but Harvard architecture have two buses. According to speed, von Neumann slower due to bottleneck, and Harvard is faster access. According to complexity, von Neumann is simple, but Harvard architecture is more complex according to von Neumann architecture. So next we discuss about three factors affecting computer performance. First one is clock speed and number of CPU cores, and memory system like RAM speed, cache size, bandwidth, like those things. Next we discuss about how each factor impacts performance. So clock speed means high speed allows more instruction per second, and number of CPU core means more cores increase the ability to run task in parallel. In the memory system, faster RAM and larger cache reduce waiting time. Next main topic is CPU functions, and we have steps in design a processor. We have 6 steps to design the processor. First one is define the instruction set architecture, ISA, and define the data path, define the control unit, design pipeline stages if implementing pipelines, and implement and test hardware components, optimize for performance, power and cost, those things. Next we discuss about instruction set impact on processor design. So determine the complexity of the data path, influence register count and types, affect pipeline design and control unit complexity, and impact performance and hardware cost. Those things are instruction set impact on processor design. Now we talk about what is instruction set. Instruction set means is a set of command a CPU can execute. From the significance, act as bridge between hardware and software, and determines processor architecture, RISC and CISC, and impact performance, speed and hardware design. Here we have example for instruction set. Data transfer, for example load, store, MOV, and arithmetic, add, sub, mul, and logical and or XOR, and control, jump, call, return, and IO instructions. So next our main topic is advanced CPU function and parallel processing. So in the subtopic single cycle processor and execution. From here, a single cycle processor executes every instruction in one clock cycle, and all processes fetch, decode, execute, memory and write back occur during the same cycle. This results in a long time but simple control logic. Next we discuss about what is pipelining. So pipelining divides instruction execution into stages, allowing multiple instructions to be executed simultaneously in different stages. Common stages include IF, ID, EX, MEM and WD. So how pipeline improves CPU throughput? So overlap instruction execution increases throughput. One instruction complete per cycle after pipeline fills, and reduce idle hardware time. Next we talk about definition pipelining. So pipelining is a CPU design technique where instruction execution is broken into multiple stages so that different stages of different instruction operate in the parallel. So next we have main two types, Superscalar and Scalar processors. So in the Scalar processor, it is instruction per cycle 1, but in Superscalar it more than 1. So in after according to execution unit, Scalar is single, but Superscalar is multiple units, and after according to performance, Scalar lower and Superscalar higher, and after hardware complexity, Scalar is low and Superscalar is high. So Superscalar processor issues and execute multiple instructions per clock cycle by using several parallel execution units. Next we have main topic is Flynn's classification. So how Flynn's classification architecture. So Flynn's taxonomy classify computer based on instruction streams and data streams. We have 5 types in here. So first one is SISD, it means single instruction single data, and SIMD means single instruction multiple data, and MISD means multiple instruction single data, and MIMD means multiple instruction and multiple data. Last we have SPMD, it means single performance multiple data. So this is variant of MIMD. We have table to and here we have all 5 types and their instructions. So SISD instruction stream 1, data stream 1 and description traditional single core processors, and according to SIMD is instruction stream 1 but data stream many, same operation on multiple data like vector processors, GPUs, those things. And according to MISD, instruction stream is many and data stream is 1. In description, rare mostly for fault tolerant systems. According to MIMD, instruction stream many and data stream also many, and multi-core CPUs describe systems. So SPMD is one program multiple tasks. Its data stream is many, and for example parallel programming, MPI, count like that. Next we have real world example. So SISD means early Intel Pentium simple microcontrollers, and according to SIMD, GPUs such as NVDA, CUDA, vector processors, and MISD space shuttle backup computing systems, MIMD, modern multi-core CPUs like Intel i7, AMD, RISC, those things. SPMD, high performance clusters, parallel scientific simultaneous. So in the conclusion, computer architecture provides a deep understanding of how computers are built and how they function, from the basic structure of input, output, memory and CPU unit to advanced design techniques such as pipelining and superscalar execution. Modern processors really heavy on efficient hardware organization. Parallel architecture such as SIMD, MIMD and SPMD enable computer to achieve high performance in scientific, commercial and everyday applications. So understanding these concepts is essential for designing faster, more efficient computing system. From the conclusion, my video is over. So if you are like to learn these things, keep watching us. Like, comment and share, subscribe us. Thank you.